Good morning, all in one and all. How is everyone doing today? Sleepy? Tired? You're waiting for the semester to end? I'm not. I think we should extend it. What do you think? Make it a 20-week session? What do you think?
No,
Give
thanks.
like 7 exams, maybe? You guys wanted to end already. It's okay. I agree. I'm pooped. I've been grading tests all week because all my 5 classes took their tests last week. So yeah, we do have to work too, guys. So don't feel like we're putting a lot of pressure on y'all. We do too. Works both ways. Well, at least I get 10 hours of sleep. I don't know about y'all, but I get like 10 hours of sleep. I'm kidding, I don't. All right, so we're continuing with 7-1. We were talking about who was running for governor. Oh yeah, it was Haley and Erica. That's right. They were running for governor. And it was a tie. They both got 43%. Man, I don't know. They'll have to do some sort of obstacle course to decide who's the winner. Maybe do a contest, hot dog eating or something like that. Something. We'll do something. All right, so I need to show you guys what does a confidence interval look like. So remember, let me tell you the purpose of what we're doing. The purpose of us looking at the confidence interval is to estimate what the actual population overall percentage is without having to count every single person in the population. Because I mean, if you think about it, how many people live in Texas? 15 million, 17 million. You're gonna go in and count every single person on a quick 1-day event? It ain't gonna happen. It takes days for someone to tally. But again, you're getting an estimate. So confidence intervals. This is what it looks like. So you're gonna be given a it looks like an inequality symbol. There's several ways that you can write a confidence interval. So confidence intervals can be written confidence intervals can be written in inequality form or with brackets. Right. So here is what a confidence interval looks like in inequality format. Inequality form. All right, so it looks like this. Was it 43? Yeah, 43. That's how it's written in inequality form. In bracket form, I think the book uses parentheses. I'm going to use brackets. 0.412, comma, 0.44. Okay, that's how you can write it in bracket form. You put it in brackets, so you don't have to use these inequalities. So you have a choice. And also you can, if you want, you don't have to leave them in decimal format. You could write it in percentage format if you want. You have 4 different ways that you all can write your confidence intervals. I'll write it with the brackets to 41.2%, comma 44.7%. So that's how you can write it. You have 4 ways to write it. That way, that way, that way, or that way. It doesn't matter. So, but notice that there are 3 digits behind the decimal, and there are 3 numbers, and the percentages. One for the tenth as a percent, and thousandths in decimal. So that's the format that you have to write your confidence intervals. So what is this meaning, right? Well, how do you interpret it? Okay, so so visually, so you can see it, this is what it looks like. So you have your curves, right? And you have, I'm gonna put in percentage, 41.2% and 44.7%. So if you were to tally up all of the millions of votes in Texas, you will see that both Haley and Erica percentage of votes is going to be in between these 2 numbers. I don't know what they are unless I count all 10 million people to get that actual number, but you will find out if you count every single person who voted in Texas, who voted for Erica and Haley, it will end up being 43%. Right? It will be. Now, what makes these 2 numbers like right there in the middle? Well, there's this thing called confidence levels. What confidence levels do is it'll either move these 2 values closer in, or they extend it out. Right. So you have there's this other part you guys see in the white ends here. These ends. This is error. This is the error part. What's the probability that we were wrong? It was not 43%. Ooh, someone's gonna get mad. Either Haley or Erica's gonna get mad. How dare you? But there's room for error. That's what the error is. But it's saying that for sure it falls in between. But there is some sort of error that could happen. You never know. Anything can happen. But there's an error. But we can expand this further out or get closer. So maybe we can make this 40.7 and this one's 48.2 or something. Or we can move them in and get closer to 43, but you run a risk of getting them an error if that's the case. So that's these confidence levels expand the critical out or move values closer to each other. So either they move them in like that, or these get bumped out. Okay. And there's 3 of them. I used to do 6 of them, but the book has 3 of them. 3 levels are usually used in the real world. I'm going to show it to you. It's 99%, 95%, and 90. Those are the ones that we use. It's kind of like you remember the story of Goldilocks and Three Bears, right? When Goldilocks went to go, she was hungry, right? And she wanted to eat their porridge. One was too hot, one was too cold, and one was just right. Same thing happens here. So does anyone want to guess which one is the just right value from the three? Which one is the best one? Any guesses? 99, 95, or 90? Which one is the just right? The 95. That one's the perfect one. So what does the 99% do? The 99% expands this out. These numbers are expanded out further out. So you're left with less error to occur. If it's 90, the numbers get closer in. You're like, what? Is that true? Yes, it's true. It is true. It is true. The bigger the percentage is, the more wider the interval becomes, which gives you less error. I'll put it here. Interval values further apart. %, interval values closer to each other. Okay. And I can give you the technical term for confidence intervals. Let me give you the technical definition of it. So in the book it says, again, don't worry, everything's going to come together. So don't worry, you're not going to be expected to memorize all these definitions and all that. But the definition of this says, it is the probability that the confidence interval does contain the population parameter. Further. You guys can see it further apart. And you guys can see on page 300 in your book, they have the most common confidence levels. And we're going to abbreviate it. I'm not going to write confidence level, that whole expression. I'm going to abbreviate it. I'm going to put CL. Right. So when you find your CL, you need to change it to a decimal. Must be changed to a decimal. Right. So 99, what does 99 turn into in decimal format? Anyone? I go to that store all the time. 0.99. 95 is 0.95. 90 is 0.90. I think Haley won the election because Erica's not here. All right, Haley, you're the winner. You psyched her out, man. She didn't want to do the debate with you. She's like, I quit. Forget it. Slacker. No. Sorry, Haley. You got a 40. All right. Winner. Haley's the winner. You intimidated her with the debate. Yep. Excellent. That's what you do. Uh-huh. It is. All right. So interpretation. How do we interpret because that's what we're gonna find. We're gonna find these things. So you're gonna be asking, well, how do I interpret it? With all this math is just overwhelming. How to interpret I don't know how to spell interpret. The confidence interval. All right, so let's go back to our Haley versus Erica race. I should do the percentage. 41.2 less than P less than 44.7%. All right, so let's say that that's our there's our confidence interval. We found out that that's their votes for the state of Texas for governor. So how do you interpret? All right, so you don't have to write it down, but just keep this in mind when you interpret it. This is how you interpret. You're gonna write, we are the world, we are the future. I'm kidding. We are whatever percent confident that the interval from 41.2% to 44.7% actually does contain the true value of the population proportion P. And this, remember that number that was there, it could have been 99, it could have been 95, it could have been 90. We don't know which one it was to give us this, but just know that. That's how you interpret it. So again, you don't know what the actual percentage is unless you go in and you count. I mean, you can do it, but it's going to take a long while. But you want to do a real quick estimate. That's how you do it quick. It's somewhere in between there. Haley's and Erica's voting percentage that came in. It's somewhere in between there. That's all we know. And then you can make the judgment where it could be at. Of course, it could be at 43. You take the average. Boom, it's 43. So that's how you interpret it. All right. So how do we get that line? Good question. How do we get that line? All right. So this graph that I showed y'all. Right. You want the number to fall. You want the actual number to fall right in the middle. Hopefully, when you count all those 10 million votes, it does fall within those two limits, right? But what if it doesn't? What if it falls in the white area or the green? I guess I should put it in green. What if it falls in the green area? Then what? Well, then we need to know what that area is. And that area is called the critical value. Critical values. Now, the critical value is this line right there. I know it's a 41.2, but what is it if I converted it back to standard normal? I want to know what that number is. I want to know what that Z number is. What is that Z, those Z numbers that cut them off there? Right in the middle, that's the boundary between the accepted and the rejected part, the error part. I want to know what that is. That's what the critical values are. So they abbreviate critical values as Z, and it has a subscript. It's a, y'all know what that is? What is that little thing there? Do y'all know? What is that called? Anyone know? What are you drinking? Vodka. Very good. Aqua.
Aquafina vodka.
Aquafina. The best. The best. Anyone know what that? It's a Greek letter. Anyone know? Anyone know? Anyone know what that Greek letter is? No, it's not Jesus fish. No, it's not. Gosh, I didn't think about that, but no. It's called alpha. 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 Alpha divided by 2. That's what that is. Alpha divided by 2. 2. Right. That is important because this is going to determine our margin of error. What the heck is margin of error? Well, I'll get to that in a minute. So critical value is the number on the borderline separating sample statistics that are significantly high or low from those that are not significant. Why is it every time I hear the word significant, I think of Snuffleupagus? You know who Snuffleupagus is? Who is Snuffleupagus? Who is Snuffleupagus? Anyone know? Anyone know?
Is it off of Doc McStuffins?
Huh?
Maybe not.
Well, no. It's Big Bird's best friend. Remember? You remember watching Sesame Street? The elephant? Hey, Big. He's always high. I don't know. He's up to no good. He's always in his room. Hey, Big Bird. He's got all huge eyelashes. We don't know. We don't want to know the details, but I think he's high. But I like yours, Ms. Johnson. They sound like muffins. Did you say muffins? Yeah.
No, I said Doc McStuffins. It's like a kid's show.
Oh, what is it called? Doc
McStuffins. Like the little girl's like a doctor and she like operates on stuffed animals. I don't know. It just sounded like a name from off of there.
Oh, I'm gonna have to watch that. Where do they show that on PBS?
PBS.
Really? Okay, I'm gonna have to check it out. Right. So she operates on stuffed animals, huh? I wonder how much she gets paid. I wonder if it's like gross. Oh, with all the stuffing. Oh, I would faint. I would faint. All right, critical value. All right, so that's what that is. All right. So what's the significance of critical value, right? So this critical value will in turn help us. Critical values will help us determine the margin of error. We call it margin of error, but it's margin of error. You're like, what the heck is margin error? That margin of error is this green piece there that we want to avoid. We don't want to get in that area. We want the actual number to be in there. So that margin of error is the green shading. That's what the margin of error is. Okay, so let me give you the definition of margin of error. There is a symbol for it. We use a capital E. E represents the margin of error. Margin of error. What is the definition of it? When data from a simple random sample. Wow, you guys can't even see it. Why did I zoom in so close? Simple random sample are used to estimate a population proportion. The difference between them the sample proportion p hat and the population proportion p. Is an error. So I'm gonna let you copy that, and then I'm gonna give you the formula, but we're not gonna use the formula. All right. I'll show you the formula, but we're not gonna use it. I'm gonna show you how to do this with status. Brace yourselves. Here comes the formula. All right, there's the formula. All right, impressions. What are your impressions of the formula? Any impressions? Does it look complicated?
It looks
So-
like a sad or like an angry face in a house.
This part? Yeah, I
That part,
see.
like the kind of like the M looks like a frowny face and then the eyebrows.
That's right. Or the what do you ladies call them? The Sharpies. You ladies know what I'm talking about, right?
No.
My sister has them. She shaves her eyebrows and then she put like she uses those little pin things and then she puts like, you know what I'm talking about, ladies. You're all quiet. You know what I'm talking about.
I don't know. I don't have angry eyebrows like that.
Yeah, well, she looks like that. And I'm telling her, ¿Por qué estás enojada? Why are you mad? I'm like, I'm not mad. Yeah, look, you got your eyebrows. They're like, look mad. She always looks mad.
You know,
Why
it
you
looks like
mad, girl?
an angry house. Is what it looks
Yes, it's like a, because she's inside an angry house. There you go.
That's what it looks
Yeah, so
like.
I do have a Sharpie here somewhere, and I go to her house and I kind of help it. I try to make her into a Vulcan from Star Trek, but it's like gold. It's like a gold pen. But I don't know if she likes gold. Well, you ladies like gold, right? So I can use gold. She'll like it. She'll get used to it, right? You know people who do that, don't y'all? You know what I'm talking about. All right, so we're not going to calculate that using that formula, okay? We're going to use StatDisk. So on StatDisk, it's going to be quick and simple, people. Quick and simple. StatDisk. All right, so you're going to go on, first of all, we need to figure out where do I go on StatDisk to get what I need to get. So you got to remember, this section is called estimating a population proportion. Right, proportion. All right, that's the name of our section. Right. So on StatDisk, here's where you guys are gonna go. You're gonna go to, I have my paper here somewhere. I had it here. Okay, I found it. So you're gonna go to analysis. Go to analysis. Then you go to confidence intervals. And then you go to proportion one sample. Proportion one sample. Right. So anytime a problem asks you on the problem, it's going to ask you find margin of error or confidence interval. Okay, you're gonna go there. So you're gonna have to read the question very carefully to decide where you're gonna go. So this is the first. Okay. find margin of error or confidence interval. All right, so what do we need to find? What do we need? What do we need? Need to find the following in the problem. Okay, you're gonna need to find the confidence level. Okay, you're gonna need to know the sample size and you need to know the number of successes. This is what you need. Okay, so every time they ask you, find the margin of error or find the confidence interval for this section, estimated population proportion, you're gonna find these three things in the problem. All right, so when you find them and you enter it in StatDisk, I'm gonna tell you the rounding rules. Margin of error. Do not round. Okay. Confidence interval. Round values to 3 places behind decimal. Then convert to a percent after. So I'm going to show you in a minute. I'm going to go to StatDisk and I'm going to show you what it's going to look like when you go to analysis, confidence interval, and proportion one sample. I'm going to show you what it looks like, and you'll see what I'm talking about. You're going to have to enter these 3 numbers. Okay, very simple, very simple. No yawning. Now I'm craving Aquafina water now. Hey, can you pass it over? Go ahead, put it over on the. Thank you. Delicioso, fabuloso. No, you don't want to drink fabuloso. Okay, so let's see. Let me show you all and what it looks like in StatDisk. All right. Hopefully I have it up. I don't think I put up StatDisk up. Oh, I didn't put StatDisk up. Okay, sorry. Okay. So you go in StatDisk, you're gonna go to analysis. You go to confidence interval right there. Right there is confidence interval, and you click on it. For chapter 7, we're only doing 2 sections, and that chapter is just for 1 sample. So the proportion 1 sample is 7.1. The mean 1 sample is 7.2. So those are the only 2 that we're doing. 7.1 is proportion 1 sample. Section 7.2 is mean 1 sample. We used to do standard deviation 1 sample. We don't do that anymore. So we only do proportion and mean 1 sample. So we're going to click on proportion because that's the title of our section, right? Proportion 1 sample. I'm going to click on it. And voila, there are the numbers that you're going to look for in the problem, and you're going to type them in. Notice that your confidence level has to be in decimal, like I said. You're going to find your N, and you're going to find your X. And then you hit evaluate. And presto, your margin of error is right there. And your confidence interval is going to be the one right smack in the middle. Don't do Wilson, because that one is not what we cover in this course. I'm thinking Wilson is the little volleyball. You remember watching Castaway? Mr. Wilson, remember he was talking to the ball? That's make believe, yeah. We want the middle one, not the Wilson one. I should mark it off. That one's no. This one, yes. Right? That's how you do. Margin of error, and then you write your result and round them to 3 places. All right, so let's go back to our problem. Let's do a couple of them so y'all can see how it works. Okay, so let me see if I can find the page. All right, so on page 312, shall we start with Mickey D's? Who is familiar with McDonald's? Excellent. What is your favorite thing to order at McDonald's? Tell me, what is your favorite? Please don't say salad. Please don't say salad. Please don't say salad. The nuggets. That's correct. Do you get any sauce with that, ma'am? What kind of? No sauce. I agree. I don't like the sauce. Just, hey, plain Jane boof. Yep, I agree. I agree. Anyone else? No one else eats at McDonald's? My gosh, what? You need to get out. Get out. Where no one else goes to McDonald's? Man. Yeah, some of you are saying I'm too broke to go to McDonald's. So you eat bologna sandwiches and Spam? Excellent. All right, let's do 13. Okay, so number 13. Let's read the instructions at the top of number 13. All right, so it says in exercises 13 through 16, use the given sample data and confidence level. In each case, you got to do this. A, find the best point estimate of the population proportion. B, identify the value of the margin of error. And C says construct the confidence interval. We don't have to do D. We'll skip D. We'll just do A, B, and C. All right, so 13. All right, so who can tell me the confidence level in this problem? I'll give you a hint. The confidence level is going to be the percentage given in this problem. It could be 99, it could be 95, it could be 92, 90. What is it? What would it be for number 13? Let me read it. In a study of accuracy of fast food drive-thru orders, McDonald's had 33 orders that were not accurate among 362 orders observed. Construct a 95% confidence interval of the proportion of orders that are not accurate. You are correct. It is the 95, but I gotta change that to a decimal. What would it be in decimal? You told me 95, but what would it be in decimal? Correct. 0.95. All right. Next item we need to find. I need to find the sample size. What is the total number of items that they are looking at? Total sample size. How many? 362. Ah, you're close. It's not 362. You're close. This is tricky. I'll read it again. In a study of accuracy of fast food drive-thru orders, McDonald's had 33 orders that were not accurate among three. Oh yeah, you're right. It is 362. You're right. I'm sorry. So that's why Haley is the governor. Ah, she's the governor. I doubted you, ma'am. I doubted you. How dare me? Oh, she left. Oh no, I'm sorry. 362 is correct. And then what is the number of successes? We're looking for the inaccurate, I believe. Is that right? Not accurate. That's considered success. Number of success. Success is meaning that we don't want the accurate. So what was it, Haley? 33. Yes, you are correct. It is 33. Okay, very good. All right, so there's your N, and there is your X. I can't highlight it. Okay, so let me show you what I have. You're looking for three numbers. Okay. Now, part A says to find the best point estimate. Okay, all right. Who can tell me, there's a formula that we did on Monday for the best point estimate. There is a formula. Who can find me the formula for the best point estimate? I'll give you a hint. It was in the handout that I sent y'all through the chat. It was the very first page. It was the very first page of the handout. What? That's right. Dang it, Haley, you're on fire today. That's right. P hat is equal to X over N. So anytime, ladies and gents, anytime they ask you for the best point estimate, this is the formula that you're going to use. This is your N. This is your X. And we plug them in. 33 over 362. And divide. 33 over 362. 0.091160221. Do not round. That's your N. This is your X. Boom. I think that's the only thing you're gonna have to do manually is that. Because then B says find the margin of error. Enter numbers into step disk. Okay, enter numbers into step disk. All right, here we go. Let's plug them in. I'm gonna plug in these numbers in. 95, 362, 33 into step disk. And you guys tell me what my margin of error is going to be. Tell me if I did it right. All right, I got 0.05880 and my confidence, oh yeah, that's it. That's my margin error. 0.05880, is that correct? Is that what you all got as well? And if I didn't, what did I do wrong? What did I do wrong? It's gonna happen to y'all. Just like me. What did I do wrong? I forgot to hit evaluate. See, you gotta make sure that you hit evaluate, because otherwise, whatever you had before stays on that screen. So hit it a couple of times just to make sure. And so there's your margin error. All you do, folks, is you write it down. E equals 0.02965, and you do not round that number either. Do not round. Bam. There's your answer. No yawning. Sí, señorita. Find the confidence interval. I already did it. I already put it in StatDisk, and I think it calculated it already. If I go back to it, there it is. Boom. Okay, I'm gonna write it down. You guys are gonna have to round this one for sure. This one you're gonna round it off. 0.06151 less than P less than 0.12081. Now this one you have to round to 3 places behind. So you help me out. What is it if I round it up to 3 places behind the decimal? I need 3 behind. Oh 0.062 and 0.121. Yep. 121. Yep. Do you want to leave it in that format, or do you want me to change it to a percentage? Let's change it to, I'm going to just change it to a percentage just to show y'all what it looks like. So that would be 6.2% and 12.1%. Interesting. So the inaccurate orders at McDonald's is between 6.2% and 12.1%. Is that a good rate of inaccurate orders? Have you ever gotten an inaccurate order when you order on the drive-thru? Anyone? Never? I always get it. Always. I always get inaccurate. Great. One time my son ordered a burger and they only gave him half of a patty. What the frog? What happened to the other one? What happened to the other side? That's messed up. Or they don't put they forget the drinks. They always forget a freaking drink. Like, man, or you ask for a tea that's unsweet and they give it to you sweet. Or vice versa. Shake my head. Shake my yeah. Well, no one's perfect, but it always happens to me. Maybe it's my ex-students. We don't know. We don't know. Maybe they didn't pass. We don't know. Oh, great. I don't know. They could have spit in my food. All right. So all of them are going to be like that. But the key, folks, the key to it is you have to identify these 3 numbers. You got to find those 3 numbers. Got to. All right. Let's do another one. All right. Let's do we did 13. Let's do 15. What does 15 say? Nope. 15 Survey return rates. Or do you want to do, yeah, we got to do that one. 13, yeah, 15. In a study of cell phone use and brain hemispheric dominance, an internet survey was emailed to 5,000 subjects randomly selected from an online group involved with ears. Good move. 717 surveys were returned, constructing 90% confidence interval for the proportion of returned surveys. All right, my furry little friends. What is your confidence level for this problem? Confidence level. And then what's your sample size n? And your number of successes x. All right. 0.90, yeah. 0.90. 5 thou. And your x, what is your x? 717. Good move. Excellent. Excellent. That's correct. Okay. All right. A. We'll find the best point estimate. This one we have to do by hand. Does everyone remember the formula? What was the formula? Correct. P hat is equal to x over n. So it's 717 over 5,000. Put it in your calculator. Don't round. 0.1434. And then we can do B and C. We can do it together. We can do B and C simultaneously. We can find the margin of error. And find the confidence interval. Right. So I'm gonna type in these three numbers in StatDisk, and I'm gonna find these two numbers automatically. Oh, I want to hold. I don't like this little window for the zoom. It's 90, 5 thou, 717. Probably wait. I want to hit it 5 times. I'm the OCD. I just want to make sure. All right, there we go. 15 times. All right, there's my margin of error. My margin of error, I'm going to write it down. E equals, and just write it down how it appears. 0.00815. And your confidence interval is 0.135, I think. And 1.152. 0.152. Oh, man, at 15.2%. I usually show my students the long way of computing the confidence interval, but we're short on time, so that's all right. So you can see how the margin of error the margin of error produces the confidence interval. I can show you real quick. Someone wants to see it. Fine, I'll show. Great. I didn't mean to do that. Like, I don't see the connection, sir. How is that all connected to that? Okay, let me show you. Just for inquiring minds that want to know. Okay. The confidence interval you don't have to write it down. I'm just going to show you. The formula for it is p hat minus e and p hat plus e. So you have the left number, lower number, and you got the right upper number, right? Okay. So we already calculated the p hat. These two formulas is what you're going to calculate in order for us to get the confidence intervals. So I already have my p hat. My p hat is right there. So I'm going to write it down. It's going to be 0.1434 minus my e. There's the e. 0.00815. Okay, then I got my p. And on the other side, you do the same thing, but instead of a minus, you have a plus. Right? And if you guys calculate that in your calculator, both sides, the left and the right, you tell me what answers you get. You do that minus that and that plus that. What do we get? Let's see what we get. (0.1434) minus 0.00815 gives me 13525. If I calculate this and I do that plus that, that's what we got. See? It's the same. That's how StatDisk got their numbers, by getting this number subtracted from that number plus that to get the upper. That's what these numbers are used for. You're doing the left value. Show you a picture. This is that number, and that's that number. That's the formula. Looks like a baseball. That's how they calculate it. But of course, we take it for granted. StatDisk does it for us automatic. Ain't that cool? Ain't that nice? Y'all like these? Can you do like a whole bunch of these? Now, the other problems don't ask you to do all three of them. They ask you specifically to do one of these three. We'll find out. Let's see. Let's do another one. Let's do, okay, I'm gonna let you guys pick. Let's see what interests y'all. Y'all want to do births, fast food accuracy, oxycodone? Y'all know what oxycodone is? That's some good stuff. Y'all know what oxycodone is, right? It's like Vicks. Touch therapy, cell phones and cancer, Lipitor. Oh, that stuff is good. I use that. Quiet. Smoking stopped. Which one interests y'all? You want to do smoking stopped, Lipitor, cell phones and cancer, touch therapy, oxycodone, fast food accuracy? I know that's an even one. Or births. Which one would you like? You all pick. Which one interests you all? We can do two if you want. I don't mind.
Touch therapy?
Touch therapy. That's a very touchy subject. Get it? Very touchy subject. No. Okay, never mind. My jokes are not good today. There goes your grades. There goes your grades. Interesting. This is probably the only Hispanic mentioned in this textbook. Interesting. All right. Anyways, just an observation. 21. When she was 9 years of age, Emily Rosa did a science fair experiment in which she tested professional touch therapists to see if they could sense her energy field. She flipped a coin to select either her right hand or her left hand, and then she asked the therapist to identify the selected hand by placing their hand on just underneath Emily's hand without seeing it and without touching it. That sounds creepy. Among 280 trials, the touch therapists were correct 123 times. All right, here we go. So what is, let's see, given that Emily, all right, so let's look at 21. Given that Emily used a coin toss to select either her right hand or her left hand, what proportion of correct responses would be expected if the touch therapist made random guesses? They're saying it mimics a coin flip. What's the probability of flipping a coin? Anyone? Flipping a coin is what? What's the probability of flipping a coin and getting a heads or a tails? Correct. 50%. That's part A. All right, cool. B, using Emily's sample results, what's the best point estimate of the therapist's success rate? Oh, what's your, okay, so we're trying to find the best point estimate. Oh, wow, I didn't expect that. Well, what's the formula for it? P hat equals X over N. What's your X and what's your N for number 21? I think your N is 280. Is that correct? There are a total of 280 trials, and how many times were they correct? Oh, one, two, three. All right, so I have P hat equals 123 over 280. That's my best point estimate. I'm going to type it in my calculator, and I get 0.439285714. Uh-oh, hold on. Yeah, I can't find it. There it is. There it is. Boom. All right, there's your best point estimate. 0.439285714. All right. C, senor. C. What is C? What does he say? Using Emily's sample results, construct a 99% confidence interval estimate of the proportion of correct responses made by the touch therapist. All right, so what are they asking us to find for letter C? Are they asking us for the margin of error or the confidence interval? I think they're asking us to find the confidence interval. All right, so we're gonna have to find all those three things again. So I'm gonna have to find my confidence level, my sample size, and my number of successes. All right, so what was my confidence level for this problem? Oh, 0.99. And my sample size was 280. And my number of successes is 1, 2, 3. All right, let's plug it in into Statistics. Uh-oh, I got cut off. There. 0.99, 280, and 1, 2, 3. All right, is my answer E equals 0.07640? Or is it the middle one? What did they ask us specifically to find for part C? Didn't they ask us for confidence interval, you know? Confidence is Cavender. Confidence interval is 0.363. I'm gonna write it in bracket format this time, just to be different. 516. All right, so I'm gonna write it as 36.3% and 51.6%. I'm gonna write it in bracket format. Little different style. So they want to know, is Emily doing a good job at this experiment? What do y'all think? Those are the numbers. She's identifying the energy field between 36.3 and 51.6%. What do you think? Is she doing a good job or not? Well, it's a little bit better than 50-50 because that was flipping a coin, right? That's just random guess. So based on these numbers, do y'all think she's doing a good job? Right? The higher the numbers, the good that she's doing. The lower the numbers, the bad she's doing. So to me, I think Emily needs to get a job. She's only 9 years old. Sell lemonade. Or Girl Scout cookies. Buy a did y'all hear about what happened in was it Colorado a couple years ago? The Girl Scout cookies were selling their cookies in front of I think it was kind of like like a what's it called, Planet K type places in Colorado, and they were making a lot of money. Of course they were. They were selling marijuana in that places, and they wanted munchies. They were selling out like hotcakes. Man, entrepreneurs, man, good move. Yeah. All right, makes sense how that works. These are fun. All of them are gonna be like that. All of them. All of the problems are gonna be like that. Let me see. Yeah, I already have that on there. You want another one? We can do another one. Pick another one. We did Emily Rosa. Is there another one in particular you guys want to see other than the touch therapy? What have y'all heard of with the Lipitor? Not the Lipitor. What have y'all heard about oxycodone? Who can tell me what is oxycodone and what are the bad effects of it? Or has any of y'all ever tried or had to be put on oxycodone? Anyone?
I have. It's an opiate, and it's highly
Is it?
addictive. Yeah.
And does it really really get you really? I mean, of course it'll knock out the pain, right? But I bet it's an addictive.
I don't know. It didn't work for me. I didn't like it.
Oh, good. I've never had to get that, but I bet that thing is super addictive. I do Vicks. That's what I do. It does the job. Same thing, but you don't. I guess you could consume Vicks. I've heard people do it, but I wouldn't do it. But yeah, that's a very addictive. So you want to do that one, or you want to do another one? We can do an odd one if you want. Births, fast food accuracy, cell phones and cancer. Ooh, cell phones and cancer sounds interesting. You want to do that one? What do you all think? What is your personal opinion? Do you think cell phones cause cancer of the brain or just cancer in general? What do y'all think?
Yes.
Yes?
Yes. Like long-term effects, like all these new smartphones, we don't really know the long-term effects of them. And I
Right.
feel like they could be messing with our brains, like Bluetooth and stuff.
Yeah.
What are those waves doing to our brains?
Yes, exactly. And they keep increasing the what do you call it? They keep increasing the, I guess, the data usage or the power of getting data, right? Every upgrade that they do. So yeah, it could. Now, how many of y'all use a microwave oven to cook your food?
I do.
Do you use it every day?
Just about.
Did you know that produces more radiation than cell phones?
Yeah.
Yeah. Hey, but the food comes out good. You gotta have your hot pocket. Yeah, we use ours as a storage. As most Hispanics do, we use stuff as storage. But yeah, I agree. I think the more powerful a cell phone is, the more dangerous it becomes. I mean, you're like all this data that's like right now with our computers, right? We're getting internet, right? It's passing through our bodies. It's passing through. You don't think that's dangerous? It's like, nah. It does in the long term. It does affect the body, but not like instantaneous. It deteriorates, right? I mean, so does water too. I mean, the water that we drink too, if you think about it, water is stored in the bottom, right? And where do we have our nuclear bombs? They're stored below in the ground. I'm pretty sure they seep radiation, right? And all that radiation goes to our water, and yet we consume it. They say that it's contained. We don't know. We don't know. And all the pollutants that they drop in the ocean and the water and the land. Yeah, we consume all that. Yeah, it's all bad. It's all bad. But hey, enjoy your hot pocket while you can. A study of 420,095 Danish cell phone users found that 0.0321% of them develop cancer of the brain or nervous system. Prior to the study of cell phone use, the rate of such cancer was found to be 0.0340% of those not using cell phones. The data are from the Journal of the National Cancer Institute. All right, so who can tell me what's wrong? There's something wrong with this problem. I know we're looking at the cell phones and cancer, but there's something wrong with the study. Before we find all these things, I mean, we're gonna find all that stuff quickly. But what's wrong with the study?
It's a
Why?
causation.
True. And where is the study conducted? Do y'all see where the study is conducted at? Is it in Denmark? Do they have the same lifestyles as people in the United States do? Can we rely on their data to say that US is the same as Denmark?
Like it's like too small of a sample size to really
Right.
make conclusion.
That's right. Why didn't they do the study in the United States? Why did they have to do it in Denmark? Yeah, I'm gonna start having an accent, a Danish accent. Yeah, I don't know how their accents go. But yeah, that's an issue right there. Why are they basing the decision of whether or not cell phones develop cancer if you're going somewhere else? So all right, so we'll just go with it. What is your confidence level for 23? And what's your sample size? And your number of successes? What do y'all think? I can chat it to me if you want. So your N is this 420,095. And the level, I believe, is 0.90. Is that correct? I got that from part A right there. There's your 90. All right. Now I gotta find the number of successes. We're missing a number. They didn't give us a number of successes. How do we find X? Interesting. All right. So let me read the first sentence in the problem. It said a study of 420,095 Danish cell phone users found that 0.0321% of them develop cancer of the brain or the nervous system. Right, so that sentence is telling us, they're kind of giving us a hint of how to find the X. So because they don't give us the X, we are given the total and we're given the percent that develop cancer. So let me show you what we're going to do. Since X is missing, we're going to use this p-hat formula, best point estimate. And what we're going to do is we're going to have to write down what we know and what we don't know. I do know my N. My N is the 420,095. $420,095. I do know that. And I know my p-hat. They told me the success or cancer, how many developed cancer. It said it was 0.03, 0.0321% had cancer. So I'm just showing y'all the long way of doing it. Okay. So there's my formula right there. So if you do the algebra in this thing, right, you're trying to find X. So you would have to multiply both sides by 32095 and you get your X. So in a nutshell, this is what we do. This becomes, if you want to convert and you want to solve for X, the X formula becomes p-hat times N. If X is missing, you would use this formula. And so I know that it's 0.0321% times 420,095. I got to move my decimal. That would equal 3 zeros. 321 times 420,095. Right, I gotta move my decimal 2 places. And I calculate that. 0.00321 times 420,095. A total of 134.850495 people had cancer. Well, you can't have 0.85 of a person. So what I have to do is I'll have to bump it up. So technically, it's 135 people have had cancer. People cancer. And that's how you find your X. So I'm gonna erase the this part. I shouldn't erase the other one. But anytime they don't give you your X, you will have to remodify your best point estimate formula and change it to X equals fun. Looks like fun. X equals fun. And so that's how we calculate that X. You have to multiply the p-hat times the N. This was your p-hat number, the 0.0321%. Okay, now we're ready. Let's plug it into our stat disk and see what our confidence interval is for part A. Right. So it says plug it in 0.90. Yep. 420 thou. and 135. Even if that number was 134.2, you would always bump it up. You can't have a part of a person. You got to bump it up. Always bump it up. All right. And I hit it. And there is my confidence interval. Ooh, now there's a problem with this one. Notice that if I round that number to 3 places, I'm going to get 0 on the left side of the interval. And I will also get 0 also on the right one. So what do? Holy cow, I can't have 0 less than or equal to 0. So anytime you're supposed to round to 3 places, and you can't on this one, you cannot. You would go ahead and round to 4 places as opposed to 3, because if you do 3, it's going to come out to 0. So we would have to round to 4. Because not enough digits to round to 3 places. Right. So our answer would be 0.0003, and the other one would be 0.0004. I'm gonna leave it in decimal, but it would be 0.03% and 0.04% of the people develop cancer of the brains due to cell phones. So, conclusion, this is just in Denmark. In Denmark, is there a problem with cell phones and cancer while using, or is there a problem in Denmark with people using cell phones? Is that causing cancer of the brains in Denmark? This is just in Denmark. That's a very low percentage of people developing cancer of the brain. But again, that's in Denmark, not in the United States. So that was answering question B. The rates of cancer due to cell phone usage is extremely low in Denmark. Right. In Denmark. We cannot assume the same in the US because of the sample size and lifestyles. I don't know, they have restrictions on who can buy cell phones in Denmark. I've heard some countries that do not permit youths like 18 years or less to have a cell phone. And so that could also be a factor. I don't know. It could be also how many cell phone providers are in Denmark. So many issues that come up. We don't know. But we cannot relate that to US. So two different populations. So you start thinking stuff like that. Whenever you do studies like that, you start thinking, what are the benefits? What are the flaws in conducting the study? So yeah. Questions? Any questions? You guys are awfully quiet today. What's going on? Is the cold front coming in today? I don't know. You're watching The Bachelorette? No?
Just
No one watching it?
tired.
Tired? What? Yeah, I hear you. Me too. Hang in there, just 3 more weeks. And then y'all have, I think you're gonna have 5 weeks off, I think. 5 weeks off. What to do for 5 weeks? Y'all can go to my house and go cut the grass if you want, and wash your car. If you want, I'm just saying. Just saying. Just throwing it out there. Allergies are killing me. Oh, man. Do you have Vicks? Alyssa, do you have Vicks? You need Vicks. Go buy some Vicks. Oh, you need a new one? Go to Costco. They have the gallon size one, in case you're interested. My sister bought one. Dang, it's huge. Freaking industrial size. The heck? Why'd you buy that tub for, man? It's like, well, in case there's an apocalypse, I gotta be ready. You can just jump into the Vicks, and then you're safe. All right. So there you go. There's how to do confidence intervals, finding the margin of error. You gotta find these 3 things, and you gotta read the instructions. What are they asking you for? Are they asking you for margin of error? Are they asking you for best point estimate? Are they asking you for confidence interval? What are they asking you specifically? So you have to read carefully what they're asking for. It's easy. I'm telling you, it's very simple. You just have to have these 3 numbers. This one, 23, was difficult because they didn't give you the X, but the other ones, they'll give you the X. You just have to read it carefully. And wow, it's simple. You don't have to do any manual calculations besides the best point estimate, but that's how it works. Okay, so that's how you do confidence intervals and margin of error. All right, so that's this part here, right? Finding margin of error or confidence interval, right? There's the second part in the book that you're gonna have to do besides that. So here is number 2, second part. So the second part is going to be finding the sample size. This is number 2. Yeah. Number 2, finding the sample size. All right, so if you all are thinking of getting your master's and doctorate degree, which you should, they're gonna ask you in your study, you're gonna figure out, well, how many people am I gonna have to sample to make my study good or acceptable? So the way we do it, you can do it manually if you want. That's totally fine. You want to look at if you look at the manually ones, there's a formula I was telling you. Look, that's how you compute the confidence interval. Look, boom. These are the formulas that we would use if you're going to do it manually. And I'm not going to show you how to do it manually. We're going to use StatDisk. So to do StatDisk, you're going to go to page. The second page, there's the margin of error confidence interval. It has it all titled, folks. You just have to read. You just have to read the pages. There's finding the margin of error and confidence interval page. That's page 2. And we go to the next page. This one says finding sample size. It's all there in that handout. Does anyone need me to send you the handout again? I can send you the handout again if you want to our chat. I can do it right now.
Yes, please. I accidentally deleted it.
What? Oh, dare you? Oh, I'm gonna have to unfriend you on TikTok. There you go.
Sir, that's too far.
I'm kidding. I'm kidding. All right, we're back. Sorry, I only said to Alyssa. Sorry, Alyssa. There you go. It's sending, and I think it was successfully sent. There you go.
Thank you, sir.
Go, ma'am. All right, so it's all labeled, ladies and gents. It's all labeled. If you all want to know how to do it manually or how to use StatDisk, everything I labeled, everything's for y'all. There, it's on page 2. How to do margin of error, confidence interval, how to do sample sizes out there. Hey, I even put a page on there. If you have a graphing calculator, it'll show you all how to do confidence intervals using a graphing calculator. If you have one, if you have one of these, it does do confidence intervals. Just follow the flow chart. It'll show you how to do it. I know a lot of you do not have graphing calculators, but I even put that on there for you all in case you all want to see it and do it on a graphing calculator. But it's all there. It's all there, folks. All of the, and it even tells you where to round and where not to round. It tells you everything. I stayed up till 8 o'clock at night doing this for y'all. 8 o'clock, that's late. Look, it even tells you where to round. Everything. It tells you everything. Look, don't round. Enter the following. It tells you everything. All right, so let's go to page 3, and I'm going to show you all how to do sample size. So you're going to read the problem, and you're going to look for those words. Find the sample size. So on StatDisk, you would go to analysis. You go to sample size determination, and you're doing estimate proportion, because the whole chapter is all devoted to proportion. The whole section is devoted to proportion. So you're going to go there. You'll get this screen, not screen, but screen. It's trying to focus. Trying to, anyways, it's trying to. It's not working. It's like me getting up in the morning, all full of alangas in your eyes. There's your confidence interval. If you're gonna look for your confidence interval, you're gonna look for the margin of error value in the problem, and it's gonna give you. Here's the thing. Sometimes they will give you a third number. If they do give you a third number, you plug it in there. And they do not give you a third number, you're going to go ahead and leave it blank. So sometimes they'll give you 2 numbers. Sometimes they'll give you 3. You'll have to enter that number if given. If not, you leave it blank. This one, don't put anything on. You just leave it blank. You don't need to put in anything on there. So be careful with this number. It'll give you the number sometimes, and sometimes they don't. We'll see. We'll see how it works. Once you enter those numbers, you hit evaluate, your answer will appear right there, automatically rounded off for you. You're done. Very simple. All right, so let's practice. Let's practice this finding the sample size. So you're gonna go to your book. We're gonna go to page where is it at? What the? There it is. Problems 31 through 38. And there it is right there. Look, it says determining sample size. Boom. And remember, this is 7.1 still. We haven't moved on to 7.2. This is still 7.1. All right. So do we have any lefties in the class? Are there any lefties in the house? Left-handed people? No one's left-handed? That's rare. That is weird. Everyone is right-handed. Is that correct? Am I assuming correct? Oh my gosh, you know what that means? I'm gonna have to deduct 25 points off of y'all's test because no one participated. That's messed up. Interesting, interesting. You know they say about lefties, they're smart. What was that look? What was that look? Wow, that was messed up. I'm gonna tell. Que mala. Oh well. They're just jealous. All right. Find the sample size needed to estimate the percentage of California residents who are left-handed. Use a margin of error of 3 percentage points and use a confidence level of 99%. All right, A says, assume that P hat and Q hat are unknown. Okay, so what do I need to find for my sample size? I'm gonna write it down here. You need, what do we need? Need the following. All right, let me switch it. All right, we need confidence level. Okay, of course that has to be in decimal format, right? In decimal. We're going to need the margin of error. All right. That also has to be in decimal. And we need to know, it says P, it should have been P hat. P hat, if given. So that's what we need. P hat, if given. Why did I put the comma? Leave blank if missing. All right, so that's what you need. You need these 3 numbers. All right, what are we doing? We're doing number 31, left-handed. All right, 31. Who can tell me the confidence level, the margin of error, and the P hat? Let's do 31. Wait, my stomach's making sound. All right, let's see. What is your confidence level for number 31? Oh, I see it. I think it's 0.99. Is that correct? 0.99? There it is, 0.99. I can't highlight it. Margin of error. Oh, it's 3 percentage points. Let me write it down. 3 percentage points. 3%, how does that change into decimal? Is it 0.3? Is it 0.03? Yeah, it's 0.03. 3% is 0.03. How did I know that? Someone just asked. How do I know that? You get your 3 and you divide it by 100. That's how you get 0.03. You can try it out. Any number that has a percentage, you always get that number divided by 100. That's your decimal. What is P hat? I think it said that it was unknown. Is that correct? assume that P hat and Q hat are unknown. So we're gonna leave it blank. Leave blank. All right, here we go. Let's plug it in. This is what I have. 0.99, 0.99, 0.03. I'm gonna leave blank. All right, plug it in. Here we go. Do, 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 do. Analysis. You're gonna go to analysis. Sample size determination. Analysis, sample size determination. And you're gonna do estimate proportion. Again, you're gonna go analysis, sample size determination, proportion. That's where you go on StatDisk. You're gonna go there. It has it on the third page of your handout that I just emailed you. It's the third page. We're looking at the third page. And it has a flow chart how to get to it, right? You click on it, and there you go. You start typing in your numbers. 0.99. Oh, I already have 0.03 already on there. And I'm gonna leave the third one unknown, and you hit evaluate. Booyah! There's your answer. 1844. The end. That's it. That's all you do. The end. There it is. There's your answer. 1844. And then part B, you're going to do the same problem. You're going to get your confidence level. You're going to write down your margin of error. Which was again 0.99. And I think it still was 0.03. But in part B, they give you the third value. They tell you P hat is, let's see what it is. The P hat number is 10%. 10%. I gotta change 10% to decimal. So 10%, I'm gonna get 10 divided by 100. I believe that is 0.10. And I'm gonna enter all these three numbers now. Right, that was given now. This P hat was now given. If it's not, you leave it blank. If it's given, you go ahead and fill it in. And you type them in. Type it into StatDisk, and that'll give us our sample. I'm sorry guys if I'm going slow. I have to go slow because this stuff is very it's easy. I know it's easy, but it's very you can get confused easily. Very confused easily. I have to go slow. Sorry. 0.99, 0.03. I'm gonna put my 0.10. And there's my sample size, 664. Yeah, 664. That's all you do. That's all you do for sample size. We can answer part C if you want. How do the results from part A and part B change if the entire United States is used instead of California? It shouldn't change. It should be the same. You don't have to answer part C. That's fine. I just want you to do part A and part B. I'll just be happy with that. I want to do chickenpox. Actually, I don't want to do chickenpox. I already did chickenpox. How many of y'all have had chickenpox? Sabrina, no. Yeah, I knew you weren't going to get chickenpox because you got vaccinated for it as a kid. So, anyone get chickenpox as a kid?
I did.
You did? Interesting. How was it? Was it bad?
Very.
Yes. I got mine in third grade. We were going on a field trip, and man, I just felt miserable the whole day. I just wanted to faint. And then I got home, and I was like, "Mom, why do I have this bump in the back of my neck?" And then she's like, "Let me see." And then she lifted my shirt up, and it was all full of chickenpox little pimples. Oh, it was terrible, man. It was bad. But you know, Savannah, that since you had chickenpox and I had chickenpox, when we get older, we could get shingles.
I know.
So,
I don't look forward to it.
I know, and they say that one's painful because all of the little bumps form along your vertebrae and your spinal cord. They all
Ooh,
form there, and
ouch.
it hurts bad. It hurts bad. So we need to get vaccinated. Great, another vaccination, right? Besides COVID, we gotta get shingles. Yep. So yeah, I got shingles. Yeah. I don't want to get shingles. All right, let's do another one. Shall we do an odd one? We can do an odd one. We won't do the chickenpox. Shall we do 33? Bachelor's degree in 4 years. It took me 10 years to get my bachelor's. Huh. Okay. Let's do 33. All right, 33. In a study of government financial aid for college students, it became necessary to estimate the percentage of full-time college students who earn a bachelor's degree in 4 years or less. Find the sample size needed to estimate that percentage. Use a 0.05 margin of error and use a confidence level of 95. Okay, so I already know my confidence level is 0.95. Oh, they gave me the margin of error automatically. They didn't have to change it. We don't have to change it to decimal. It already came out decimal. It was 0.05. Now let's see, do they give us the p-hat number? I need to change that on my stat list. I need to put p-hat. All right, A, assume that nothing is known about the percentage to be estimated. All right, we're gonna leave that one blank, people. It says leave blank. All right, sample size. All right, I'm just gonna type in the 95 and the 0.05. That's it. That's all I have to do on my stat disk. Why did it get out? Hello, everyone. Where's that disk? What the frog? Hello again. Hello again. What the frog? Why is my stat disk not working? Hold on. I think it cut me out. There you go. Sorry. All right, here we go. 0.95, 0.05. Leave blank. Answer is 385. Too easy. The end. There's part A. Part B, you do the same thing. You keep your confidence interval the same, 0.95. Your margin of error is 0.05. But this time our p hat for part B is 40%. Ooh, I gotta change 40% to a decimal. Divide 40 by 100. That gives me 0.40. I'm gonna enter that 0.40 in the third option. 0.40. Answer is 369. There's my sample size. You guys want a whole bunch of these in your test? Your next one? What do you think? Would y'all be able to handle like 1,000 of these? What do you think? Are these easy or not?
If I'm left-handed, do I get out of it?
No. If you're ambidextrous, then.
Oh yeah, I'm ambidextrous. That's
Are
me.
you? You can use your feet as well?
Yep, all four.
Ah, you don't want to see my toenail. My toenail is like, it's like curved and it's black and it's got like fur on the side. Don't know why there's fur on the side. But yeah, I can grab a pen like that and then use it as a pen. I can't do my penmanship like it, but it can do a line. It can go like that. That's it. But that's as far as it can get with my toe. But everyone's different, you know? Everyone's different. Okay, so I'm sorry I took long with this section, but I'm just showing y'all the steps that the critical thing, people, look. You have to rely on this handout that I sent you. In order for you to understand how to do stuff on StatDes, you gotta find the page that specifically tells you what to do. You follow the instructions. You type in what's asked for. You gotta go to the problem and find those things. This handout is going to save your lives. You gotta print it. You gotta use it for your exam. You gotta use it for your final. I'm just letting you know, it's critical. Put it under your pillow. You don't have to memorize it. You don't have to memorize it. You just have to use it and read it. Read it, read it. Now we're just giving you the logistics of how to maneuver through StatDisk. When we do the next section on Monday, we're gonna go through this quick because first, the items are pretty much similar. You know how to use StatDisk. We just need to enter and find these things that I'm gonna show you on Monday, and it's gonna be swift and quick. So you'll be able to get it. So practice 7-1. You gotta practice 7-1, do 7-1, and then we can get to 7-2 quick. It may take us like an hour to do 7-2 because it's super quick, very easy. And I'll show y'all. All right, so we will stop here because we only have 1 minute left. And I kept y'all overtime last time, remember? Y'all didn't complain, y'all were all quiet. Y'all were so nice.